to Wisdom University. Today we'll be looking at chapter 4, which is implementing firewall technologies. So without much ado, let's begin. Now, first of all, let's take a brief look at firewalls. What do we understand by firewalls, and what are the things that we need to do in order to super protect our network? Now, we say network firewalls separates protected system or protected network from non-protected system or non-protected network or non-protected areas, preventing any authorized users from accessing any protected network's resources. So here we have a protected network. So when we build a firewall, let's say, for example, this is a protected network. So I use P, okay? So here is an unprotected network, like the open internet, okay, open internet. So in order to protect this system from this unprotected system, we need to build something here before you can access this main system, which is called the firewalls. Firewalls are systems that protect our networks from any unauthorized users from accessing our system. Okay, something that prevents unauthorized user, this is unprotected. Okay, unauthorized users from gaining access to our network is firewalls. Okay, now the technology that we use in firewalls are one. We have what we call the ACLs. The ACLs. ACL represent access control list. Okay, every time you hear access list. Okay, for short, we just call it access list. So one of the technology we use to build firewalls to protect our network from unauthorized users is ACL. Okay, number one, ACL. Number two, this ACL evolved what we call standard ACL. We have what we call standard ACN. We have extended ACN, which are usually or commonly in use. And we have the numbered ACL, and we have named ACLs. Okay, but ordinarily, for a beginner, ACLs are categorized into two broad types: the file system ACL and the networking ACLs. The file system ACL, they helps to filter access to files and any directory in a network. They help to filter the access to files, folders, directories. This is the type of ACL called the file system ACL. Then we have another type of ACLs called the networking ACL. Networking ACL filters the access to the system's network. Filter the access to the system's network. Okay, so these are for a beginner. A beginner, when you talk about ACL, what we look at is to look at the two broad type of ACL, the file system ACL and the networking ACL. The file system ACL helps to filter access to files and directory or folders and so on and so forth on the system. And then the networking ACL helps to filter access to network. Now, this is for ACL, the first type of technology that is used for firewalls. The second type of technology, but in more contemporarily or academically, we'll be talking about it in terms of one, standard ACL. Academically, we'll be talking about ACL in terms of standard ACN, and two, extended ACN. Three, we'll be talking about numbered ACN. Four, we'll be talking about named ACL. So academically, we'll be looking at these four broad type of ACL. The second type of technology that is used for building firewalls, is called the advanced ACL. Advanced ACL. Okay? By the word advanced, we'll be looking at, we say, this is the type of ACL that permits or denies traffic based on 5 tuples. What are the 5 tuples that the advanced ACL uses? Number one is the source IP address. Okay, it uses the source IP address. Number two is the destination IP address. Okay, it uses the destination IP address. Number three, it uses the source port like UDP port and TCP port. It uses the source port. Number four, it uses the destination port, both the TCP and UDP ports. And number five, it uses the protocol types. The protocol type is the ICMP. Is it IP protocol? Is it ICMP? Is it SNMP? or any type of protocol that is in use. Okay, consider. So advanced ACLs, they consider 5 tuples. These tuples are the source IP address, the destination IP address, the source port, the destination port, and the protocol type. Okay, now types of advanced ACLs. We have the stateful firewall, and we have the reflexive, or what we call the dynamic ACL. The dynamic ACM, and we have also, which are time-based ACL. Okay, so the first one is the stateful firewall. These are ACLs with established keywords. They are ACLs. The stateful are ACLs that have what we call, they come with the established, or have what we call the established keyword. We're going to talk about this as we move forward. Then we have the non-stateful. Example is a reflexive or dynamic ACL, and time, they are usually time-based ACL. We're going to talk about that. Then the third type of technology that is used for building firewall is the zone-based firewall features. We're going to talk about the zone-based. Okay, this will be the last part of this section. So these three types of technology that are used for building firewalls are the basis of today's lecture. So we're going to go into through ACL, whether it be it a standard ACN, a extended ACN, numbered ACN, named ACL. We'll talk about that, and then we're done with the ACL. Then we'll go to advanced ACL. Other advanced ACL, we'll be talking about stateful firewalls, and we'll be talking about dynamic firewalls and time-based. Then after that, we look at the zone-based firewalls. Now let's move on. Okay, the next thing is the common types of firewalls that we normally have. You know, we say there's what we call stateful. Stateful, it falls under the advanced ACL. Okay, stateful fall under advanced ACL. Then dynamic also advanced ACL. But when you have standard, extended, numbered, and named ACLs, they are just a type of technology. They are just ACLs, which are types of technology that are used in this. And let's move. Common types of firewall, we said we have the packet filtering firewalls. In a packet filtering firewalls, what it does is that, you know, we have the OSI layers for network, TCP/IP network. Okay, so these layers are several layers. We've done this in the digital communication. Okay, we handled this in digital communication or networking. We've also learned this in networking, computer networking. So we have the first layer, which is called the physical layer. We have the data link layer. We have the network layer number 3. We have the transport layer number 4. We have the section layer number 5. We have the presentation layer number 6. And we have the application layer number 7. So these are the several layers in OSI TCP IP network. So these layers, every layer got its physical job. Like the physical layer, every layer got its job. Like the physical layer, you know, we use the cable and all of this to connect computers and network and devices, network devices. We have the data link layer where we enter the data. We have the network layer where you have the network itself, the router and all of these things, and the transport, router, switches, and hub and all of these things. Now, for this firewall, this is where, because we installed this on the router, okay? We installed this on the router. So this covers the packet filtering firewall, covers the network and transport layer, okay? This type of firewall covers 2 layers of the OSI model, okay? If you study networking or you study digital communication, OSI model. So you know, you learn this OSI model, the 7 layers of the OSI model, and the functionality associated with every layer of this model. Okay, so in this OSI model, we're saying that the packet filtering firewall covers the network layer and the transport layer, because this is stored to combat any issues with the router before the network can be accessed. Okay, any outside packet that is entering the new system must pass through this firewall before it goes through the router and before it gets to the local area network. So this packet filtering is in layer 3 and layer 4 of the OSI model. Now the stateful firewall covers 3 layers. Layer 3, layer 4, and layer 5. The network layer, layer 3, the transport layer, layer 4, and the section layer, layer 5. So this one covers 5 layers, the stateful firewall. So every stateful firewall, which, you know, a stateful firewall is an example of advanced ACL, advanced ACL. Okay, so this is an advanced ACL. So for this, it covers 3 layers. Advanced ACL, like we say, access control list. ACS means access control list. So for this, it covers 3 layers: the network layer, layer 3, the transport layer, layer 4, and the section layer, layer 5. So every stateful firewalls will help to protect and ensure the data are not jeopardized within this layer coverage. Okay, now let's move to the next one, ACL. Now let's start with the very first one, the ACLs. We're starting with the first one. Okay, now for ACL type, virtually any type of traffic that can be defined explicitly by using an approximately numbered ACL. Okay, any type of traffic you can use numbered ACL. For example, we will give the protocol, and then we give the range of numbers that are assigned to this type of data. Now the first one is the IP. We run from 1 to 99, and we also run from 1300 to 1999. Then for extended IP, we run from 100 to 199, and then we also have from 2000 to 2699. That's 2699. Okay, so every other one has been given the Ethernet type code 200 to 299, DECnet and extended have 300 to 399. So every of these protocol, all these are different types of protocol in a network. All these are different types of protocol. Okay, so this protocol have their own range of numbers that will be explicitly assigned to them that enable this ACL to be configured in a router. Now let's take a look at, say, in the past, the Ethernet type field of an Ethernet frame header was used to define certain types of traffic, right? The Ethernet type field was the main etiquette for defining a type of traffic. Like, for example, the Ethernet type OX 0806 indicated an ARP, that's address resolution protocol frame. So this address resolution protocol frame was 8035, OS 8035, okay, and this indicated a RAP frame, which means advanced address resolution protocol frame. So this is what it is. In the past, it just used to be Ethernet this thing that was used, but now there's a way we frame the header in order for us to easily identify what it is and what it is used for. Now let's take a look at it was also common to create ACL based on the MAC address in the past. Easily we can create ACL based on MAC address, IP address, MAC address, and so on and so forth. Okay, we're going to see all of this as we progress. Now let's move to standard ACL, which is the first type of ACL. Okay, ACL is just a technology. ACL is a technology, don't get it twisted. ACL is just a technology, a Cisco technology that is used to create a firewall, a software firewall to prevent hackers from accessing your network. Now let's take a look at types of Cisco ACLs. Now we say the standard ACL filter IP packet based on what? Based on the source address only. Standard, only source address. Extended uses beyond that. The standard uses only source address only. So this we have to take note of. The standard ACL only make use of the source IP address only. The source IP address. Okay? For the header, it makes use of only the source IP address, meaning it addresses the source IP address without considering the destination IP address, the source port, the destination port, the protocol type, and so on and so forth. All those other ones that makes it a standard, that make it advanced ACL. So this is just an ACL. You know, we have an advanced ACL. So for ACL, which a good example of just ACL is a standard ACL. A standard ACL is just an example of ACL. So a standard ACL makes use of only the source IP address. The source IP address only. Is that okay? Now let's move on. Now, for example, like you see access lists like this. Access list actually means access control list. Okay, but for short, we just write access list, which means ACL actually. ACL 1 to 99. We already said what 1 to 99 is, right? 1 to 99 is just for IP address. You can see it here, 1 to 99. The range of the number is just for IP address, not extended IP. Okay? So when you have this, you are saying access list 1 to 99 permit/deny source address source with card. So you can see either it permit or deny the source. So it's only applicable to source IP address, only the source IP address. So that's what we use only this standard ACL for. Okay? Okay, now let's move on quickly. Let's take a look at that. Still on standard ACL. Standard ACM is also used to create a standard name ACL on a router. You can, like router 1, you can give it a standard name like restrict VTY. You can create a standard name using the same standard ACL that will permit the tenant access to only the administrative host. So you give instruction, the access will only be to the administrative host. Okay, now let's take a look at what we're saying. Here you have a network, right? Here's your router, a gateway to the rest of the world. This is the rest of the world, the internet. Okay, so everything coming from the internet goes through this router. Now you can see we built like looks like brick around this router. We build a firewall around the router. So anything that is coming has to go through the firewalls before you have access to this router, and before it passes through this interface to this probably this switch, and then to this administrator, the system administrator, to a user, and this work group server. Okay, so this is a LAN. Here, what you have here is a LAN. What we have here is a LAN. Okay, now for this LAN, this router, anything coming to enter through this router has to pass through this firewall that has been built around this router before it finds access to this place. Now let's see how we use the standard ACL to create specific names or standard name, okay, on a specific router. So let's call this router router 1, and the name we're going to config. Now, so we can go to our command line interface on the router and configure this we've talked about. So you go to your command line interface and put it in the router execute mode or the privilege mode, usually router execute mode, and then you type in this interface, you type router 1 config hashtag IP. You see, we're configuring with the IP hashtag IP access list. Okay, because we are dealing with access list, we are configuring the access list. IP access list standard. You see, because we are doing standard. Say create a standard name ACL on router 1. Call it. This is what you're going to call it. Restrict VTY. So we press standard restrict VTY. You have to put the name standard VTY because this is what they have asked you to config. Now we go to the next, what we type on the command line interface to configure the router. The next thing we do is to say router 1 config standard n number of ACL, that's n numbers of ACL, okay. Hashtag remark permit only admin host. Remember, they say we should create for only administrative host. The telnet access is only for the administrative host. So you go to configure on your command line interface in your execute mode by writing, remember we said to put in the execute mode or privilege mode. In your privilege mode, just put hashtag. Once you put hashtag in your command line interface, you put it in your execute mode. So you can start to configure your router from there onward. So once you write router 1 config standard, this one means standard because you are configuring a standard ACL. Standard ACL, n number of ACL, meaning any number of ACL. Hashtag remark permit, so you must put remark. Hashtag remark, meaning what's the remark? What's the remark? Permit only admin host. That's the remark. Permit only the admin host, right? So you go, the next line you config after that is you say router 1 config standard n number of ACL hashtag permit host. You put the IP address 192.168.1.10. Look at it. That's the admin IP address 192.168.1.10. So you have to configure. Once you say permit the admin host, the next thing is to configure permit the host. What's the host IP address? You have to put the IP address number. You have to put the host IP address. Then after that, so this is the host, the admin. The admin. Okay? So you must put the admin IP address to show that it's only the admin that is allowed to have access to the tenant, that is permitted to access the tenant, to have access to the tenant protocol. Okay? The next thing is router 1 config standard and number of ACN hashtag exit. Then router 1 config hashtag, we have to configure the VTY. Okay? VTY 04, 0 space 4. 0, 1 to 4 interface, all the interface 1, 2, 3, 4. Okay, you have to configure the interfaces. You cannot configure anything on the router without bringing the interface in. So when you finish, you put hashtag exit. You now configure the interface. Router 1 config hashtag line VTY 0 to 4. Router 1 config line hashtag access class restrict VT. So you are saying access class. What's the access? Restrict VTY, and then router 1 config hashtag exit. So you've done the VTY and you've linked the VTY to the access list, to the access class. Okay, you've linked them with this line protocol. You've linked them up. You've linked them up, and then it's able to relate. It's able to relate. Now let's move on. So this is what you do. Now so that's for the standard ACL. We say other ACL. We have standard. We have extended. We have numbered ACL, we have named ACL. Before we go to standard, before we go to advanced ACL. Now let's go to extended. Extended ACL. We say standard ACL, it only makes use of the IP address, the source IP address. The standard APL only makes use of the source IP address. But what about extended ACL? Extended ACL for configuring a technology for configuring a firewall makes use of not just a source IP address. It makes use of the following. 1, it makes use of the source and destination IP addresses, both the source and the destination IP addresses. Then 2, it makes use of the protocol type, whether it's an IP, Internet protocol, whether it's an Internet control message protocol, or whether it's UDP or TCP or protocol number. It makes use of them. Okay, so you can see this extended ACL is almost more or less getting close to advanced ACL, right? So another thing it makes use of is the source and destination TCP UDP ports. Makes use of because this is the definition of advanced ACL. An ACL for configuring advanced ACL is a technology for configuring a firewall that makes use of the source and destination IP address, source and destination port, and protocol types. That's how we define the advanced, which is quite related to what the extended has. Okay, now let's move on. So you can see for the access list is from 100 to 199. You permit or deny the protocol source address, the source white card, the operator is upright, and then destination address. You can see destination address is also there, and then you see established, because extended use what? Established. There must be an established. For extended, there must be an established keyword. If there is no established keyword, then this is not an extended ACL. Okay? So you must, when you configure this, we're going to look at the configuration on the router. When we are configuring this, we're going to say establish, right? As one of the last operator that we're going to use. Okay? We configure the source IP address, the destination IP address, the protocol type, the source, and then the established protocol. Okay, so all of this must be in this type of ACL, this type of ACL, which is extended. You see, access list 103 permit TCP 192.168.30.00225. You can see you put in the subnet mask and any. Okay, 80. So it's adding everything established. You see, so everything is put in place in order for it to be an extended. If not, it will be a standard ACL. If there's no destination IP address, there's no destination port, there is no protocol type, then it will be a standard ACL, not extended ACL. Now let's take a look at this. Here is a question. extended ACL question 1. Let's see how the configuration takes place. It says create an extended name ACL called ACL1 applied incoming on the interface 0/0 interface that denies the workgroup server outside access but permit the remainder of the LAN users outside access using the established keywords. Okay, so the workgroup server should be denied access from what is coming from the outside access. But the remaining LAN, the remaining local, this is the workgroup. Let's look for the workgroup server. This is the workgroup server. You can see the workgroup server should be denied access from what is coming. Should be denied access from what is coming from the outside world, the internet. But the remaining one, like the administrator and this user, should be granted access to what is coming. Okay, so we're going to create a configuration that will match with this question using established keyword, meaning it's an extended ACL. So we say router1 config hashtag IP access list extended, you give the name. Because this is extended, this is not a standard. This is extended. After IP access list, you write extended, you put the name. Extended, then you put the name. Because you can see the name in the question. The name has been given to you. Extended must be there, and then the name must be there. Extended ACL1. Okay, that's the first one. The next one, router1 config extended. You see, now we short it extended n number of ACL hashtag remark LAN ACL. That means the LAN, the local area network ACL. Okay. Then the next router1 config extended n number of ACL hashtag deny IP host. Remember they say we should deny what? The workgroup server. So we have to say deny IP host because all of them are hosts here. Okay, deny IP host 192. Look at it from here. 192.168.1.6. You have to put the IP address 192.168.1.6 and then you put any. Okay. Then the next thing you configure is router1 config extended n a number of ACL permit TCP because they say you should permit every other one, right? Permit TCP 192.168.1.0. Then you put any other one. You put the subnet up to 225 subnet. So once you put up to 225, meaning any other computer on the network that is not this workgroup server, then you should be granted access. Any other computer on the network, on this local area network, should be granted access. Okay, should be granted access to the outside world. But this one should be denied. The workgroup server should be denied. Should not be allowed to see the. Then after that, then you put established. Then we move to router1 config extended n number of ACL. Deny IP any. Then router1 config extended NACL exit. Then we put the interface. Router1 config hashtag interface FA 0/0, and then you link the interface to what you've configured. Router1 config interface. You see, this IF means interface. Router1 config dash interface hashtag IP access group ACL interface. You see, ACL1 interface, meaning you're linking this interface to this ACL1 extended ACL1 that we've created. So once you do that, then you've configured this router. What it means is that any packet or traffic that is coming from the outside world, from the internet, if it's trying to access the workgroup server, it will be denied. It can only have access to these other network computers in the local area network. So you configure and then you put the exit mode. Now let's see for question 2. That was for 1. Let's take a look at creating an extended name ACL2 and how this question goes for this. How we can configure this for this question. So create an extended name ACL called ACL2. Apply outgoing on the FAO1DMZ interface, permitting access to the specified web and email server. So we should permit access to the specified web and email server. Remember, we've done this one for part 1. Now we want to do some work here. Okay, so what we do, so it has told us to permit access to this email server and the web server. So we should know the IP address. They are in the demilitarized zone. This is a demilitarized interface or network. Okay, so let's see how we configure this. We say that our config IP address access list extended. You give the name extended. You must say extended. Then you give this name ACL2. Then the next thing is to our config. Then this extended and ACL that you mentioned, you bring them in NACL hashtag remark DMZ-ACL. Why is it called DMZ? Because that's the type of network we have here. DMZ-ACL, demilitarized zone ACL. Okay. The next configuration is router 1 config extended NACL permit TCP any host 192.168.2.5 up to 25. Okay, dot 5, see, dot 5, 192.68.2.5, dot 6, dot 7, like that, all of them, up to maximum of this number. Okay, so the meaning you are saying it should permit the TCP protocol to access here to be able to be used here. The router 1 config extended NACL permit TCP any host 192.6. This one we are configuring for the web server. The first one was for the email server. 192.168.2.6 up to 80. Okay. The router 1 config extended NACL deny IP any, meaning deny any other thing apart from these ones. Any other thing on this demilitarized zone, deny it. Okay, router 1 config. Now we configure the interface. Interface FA0/1. Then after you configure the interface, you have to link the interface. Router 1 config interface hashtag IP address access group. Here you now put the access group ACL2 out, meaning anything that is outgoing. See, that is going out. That's the meaning of this out. If it's coming in, we'll put in here, in. Okay, that is coming in. This one means going out. Router 1 config interface hashtag exit. So it means you've done the configuration that anything that is going out should be able to use these two email server and the web server. So we configure this router to be able to enable this server, email server and web server, to be able to send anything from this place to the outside world, permit access to this web and email server. Okay, so that's that. Let's move on. This is logic. Logic, when configured, the iOS, this is the Cisco iOS, the software the Cisco use. iOS software compares packets and finds a match to the statement. When you've configured, this is how you do it in the network environment. These are routers or switches, and then this is you bring your specific computers that are designated for configuration of routers and switches, and then you enter this, all what we have learned today, to configure all of these things to protect your system, your network. Okay, so the router then logs it to any enable login facility. A good example is your cursor, your Ethernet buffer, and your syslog server. Okay, now let's go to log itself properly. Several pieces of information are usually logged, right? One is the action. We have the action, the protocol, the source and destination addresses, and then TCP and UDP, and the ICMP. Okay, now the action is to permit or to deny. That's the action we say regarding logging, either to permit or to deny. Then the second one is the protocol. Protocol, we have protocols such as TCP, UDP, ICMP, SNMP, and so on and so forth. So we have source and destination addresses. We have for TCP and UDP, we have source and destination port numbers, and therefore ICM is message, about message. Okay, log messages are processed, switched on the first packet match, and then at every 5 minutes interval after the first packet match. So every 5 minutes they will be re-evaluated. Okay, so that's that for that. Let's move view ACL operation. A useful command for viewing access list operation is the show log command. Once you type the show log command, it will bring out everything in the access list, okay, in the ACL access list. It will bring everything out, you'll be able to see. Now to reset counter, use the clear IP access list counter, okay, if you want to clear the counter. You put the clear, you have to say clear in the command line interface, clear IP access list counter. Once you type that in that command, then you'll be able to see. Now let's see. For example, interface Ethernet 0, IP address 111, there with the subnet, IP access group 1 in access list permit blah 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 blah, then log access list 1 deny blah blah blah, and then log. So these are now router hashtag show log. So here it will display whatever you have. Okay, once you type all this command, it will display what we have. Now let's go to APL caveats, ACL caveats, and the first part of it to look at is the implicit deny all statement that we can put in the configuration mode in order to deny whatever is coming into our network. All Cisco ACL ends with an implicit deny all statement. Okay, all Cisco ACLs, they end with an implicit deny all statement. Is that okay? Now, standard ACL packet filtering. Another thing that we always study with ACL is the standard ACL packet filtering. Standard ACL are limited to packet filtering based on the source IP address only, the source address. Extended ACL might need to be created to fully implement a security policy. Because if you want to implement a security policy, you need to create an extended because it covers the source IP address, the destination IP address, the source port, the destination port, and the protocol type. So you see, you need, in order to have a good security policy, you need to create an extended ACL to as a technology, or you need to use an extended ACL as a technology to create this firewall, and that will give you the security that your network is desirous of. Now, order of statements. ACLs have a policy of first match. When a statement is matched, the list is no longer examined. Once a statement is matched, you no longer examine the list. Okay, so another thing is that we should ensure that the statements at the top of the ACL do not negate any statement that is found in the lower section of this configuration. Okay, then another thing, we should place any specific ACL statement higher in the ACL and more general statement near the end. Okay. Okay, let's move on. Still on ACL caveat, directional filtering. ACLs can be applied to inbound packet, that's towards the interface, or outbound packet, that is the ones that are going away from there. So they are used, because they are technology that are used to create firewalls, they can be used to filter what's coming, what is going out. Double check the direction of data that an ACL is filtering also. You can check, help us to double check the direction of data that the ACL is filtering. The another thing is the special packet. Another thing about the caveat, ACL caveat, is special packet. Router generated packets such as the routing table updates, they are not subject to outbound ACL statements on the source router. Okay, anytime the security policy requires filtering this type of packet, inbound ACL on adjacent router or other router filter mechanism will definitely be put in place, will be used. Okay, now modify ACLs. New entries are added to ACL, okay? Not from the top, but at the bottom. Okay, anytime you add new entry, then it doesn't negate what you already have. So if you are using the Cisco iOS 12.3, sequence number can be used to edit an ACL. So here we use sequence number, although even though the sequence numbers are not visible, but sequence number are used to edit any ACL. ACL is processed top to bottom based. So, and as it's processed on top to bottom based sequence numbers are used, okay, from lowest to highest. Okay, now let's take a look at example of sequence number. We're going to look at example of sequence number. These are sequence number, lowest to highest. They are in tens, 10, 20, 30, 40, 40. So you can see any other thing we want to type on the configuration mode, it will be 70. Okay, anything, the next one will be 80. So this sequence number, even if they are not conspicuous, but they're there, this is what it is, okay, for ACL. Okay, so each one, probably each sequence represents something. Like this one is for World Wide Web, this for Telnet, this for SMTP protocol, this for POPs 3, this 21, this 21 interface. Okay, so that's that. So sequence, anytime you are modifying an ACL, you use sequence number. So sequence number helps us to modify ACL and put them in the right and in the proper place. Okay, now let's move on. ACL placement. Now let's take a look at an e-bound ACL operation flow chart. So e-bound, that's for what is coming into an ACL. Packets to interfaces in the access group. When packets get to the access group, first of all, there are three things to check. Whether it matches, whether the packet matches this place, and then we see the first one, and then we test it. Match first and test. Then if it goes through, then if it's yes, then it goes straight to permit. Okay, it goes straight to permit. Once it permits, it goes to the routing table for processing. It goes straight to the routing table for processing. If not, it goes for a second test. If it's no, if here is no, it flows down to second test. We also see this three-phase test. The match, next, and test. You know, match first and test. This one is match, next, and test. If it's true, if it's yes, if it passes at this second stage, it goes straight here to the permit and it enters the permit routing table. Then, if it's no, it goes to the last one, match, last, and test. If this match, last, and test goes through, it goes to the permit and goes to the routing table. But if it doesn't, all of them eventually falls to the dustbin. If this last one you sent here didn't meet up, it goes to the dustbin. It goes to the dustbin. The packet is discarded to this bucket. Okay, that's the inbound for inbound ACL operation. Now let's see the outbound ACL operation flowchart. For outbound ACL operation, now what is coming? You say the inbound interface packet comes in here. Okay, you can see the route. This is the outbound interface. Okay, so here, what we have here, if it comes in here, the packet comes in here, routing table entry. If yes, it goes straight to choose outbound interface. So from here, it enters this place. Once it's yes, if it's yes, it flows this way to the test. It flows this way to the test ACL statement. Okay. If it's no, it goes to another test, the permit. If it's still no, it's discarded. If it's still no, it's discarded. Okay, but if okay, like from here, then it goes straight to this permit section, and then from here the outbound comes out from the outbound. Okay, so that's for the outbound flow chart. The ACL placement. Now, what are the steps for placing the ACL in the creating the firewalls using this ACL? For standard ACL placement, standard ACL, they place as close to the destination as possible. We place them close to the destination as possible, not to the source. Remember, they use only the source address. Standard ACL filter packet based on the source address only so placing this ACL too close to source can adversely affect the packet. So we don't place them close to the source. We place them close to the destination. Okay. Extended ACL, the placing is close to the source. For extended, we have to place it close to the source. Extended ACL, we place them close to the source. For standard ACL, we place it close to the destination. Is that okay? So here is where to place a standard ACL. Where do you have to place a standard ACL? Okay. Now let's take a look at this. Here is the IP address for anything that is coming into this router. Okay, this in, this out. What's going out of this router? So here we have the IP address 192.168.1.0/24. This 168.2.0, 168.168.4.0/24. Okay, so this is the outbound interface. Okay, so where should we place a standard ACL? Now, here are the requirements. Prevent traffic from the 192.168.1.0. We are going to prevent traffic from this one network, from entry 192.168.4.0 network. So we're going to prevent traffic from this one, from entry this one. Okay, that's the requirement. So, but we will let it go to this and this. But we prevent this traffic from here to get to this place. So what will be the ACL? ACM access list 99 192.168.1.0.0.255. The access is 9, permit any. Okay, now let's see the bad location. Where will be the bad location in this case? Bad location will be meet some of the requirements. Prevent traffic from 192.168.1.0 network from reaching 192.168.2.0. 2.0 is this interface. This one is this interface, and 2.3 interface, this one. So here is bad location, but it's supposed to be where this traffic can go, because we're preventing it from this one. So the good location will be that meets the requirement is this one. So the good location will be this one. So this and this have been configured to be bad location for any traffic that is coming from this .1.0. Now we have to place the extended ACL. You know, the one we did just now is for the standard ACL. What about the extended ACL? Where do we place the extended ACL? Okay, now let's see the requirement. Use extended ACL to prevent traffic from 192.168.1.0, traffic from here. We use extended ACL to prevent the traffic coming from here, okay, network, from entry the 192.168.4.0, from entry this one. Network, but allow it to reach other network. So you can allow the traffic to reach this one and this one, but prevent it from reaching this one. So the same thing, ACL access list 109 deny IP 192.168.1.0. You put the subnet up to 255, then 192.168.4.0. You put .0.0.255, meaning prevent whatever is here from reaching what is here. Okay, and the access list 109, permit IP any. The good location in this case will be extended ACL is placed closest to source, where which prevent traffic from 192.168.1.0 network from reaching 192.168.4.0 network, but also allow it to reach other networks. So this traffic will reach this place, will go to this network, and also come to this network for extended ACL, but prevent it from reaching this one. Prevent this traffic from entering this particular network. Okay, and then the bad location will be where? Okay, this one we don't have a bad location because we only prevent it from not reaching here, but the good location is that it has to reach here and also have to reach here, right? Now let's go to what we call the dynamic ACS. This is the third type of this is a type of advanced ACL. Okay, this is a type of advanced ACL. Dynamic ACS are also called the lock and key ACS. Another name for dynamic ACL is the lock and key ACS. Dynamic ACS, they authenticate the user and they permit limited access through the firewall that we have installed, firewall router for a host or a subnet for a finite period. Okay, dynamic ACS are dependent on the following things: the Internet connectivity, dependent on the authentication for the local or remote ones, and then they also depended on the extended ACS, the type of extended ACL we've configured. Now, how do we implement the dynamic ACLs? An extended ACL is applied to block all the traffic through the router except the telnet. Extended ACL blocks all the traffic that comes through the router, but without blocking that one from the telnet. Now, users, this is where dynamic ACL comes in now. Users who wants to traverse the routers are blocked by the ACL until they use the telnet to connect to the router, okay, and authenticated. So if you are not using telnet, you are blocked, okay, if you create extended ACL. So this is where the dynamic comes in. Users authenticate using telnet and then dropped. However, a single entry dynamic ACL is added to the extended. A single entry dynamic ACL is added to the extended ACL that exists. You already have extended ACL established in your configuration. So you just put a single entry dynamic ACL, you add it to permit the usage. This permit traffic for a particular period, whether it's idle and absolute timeouts are possible also. Okay, so it only permits when you bring a single entry dynamic ACL, you add it to the extended, then you would have had a robust dynamic system. Now this is the configuration of dynamic ACL. Here is a router. Here is the World Wide Web, the Internet. Here is a remote user. Okay, this remote user may be a good guy or a bad guy. Okay, now let's see how we can configure a dynamic ACS. Now the first step is that the telnet to the router. You allow telnets to router, deny everything else. So this is the first configuration we make. We allow the telnet to the router, but we deny everything else. Step one. Step two, we authenticate user. We're going to authenticate the user. Okay, how to do that? You either use the local method like the username and local method by using password and username, or use the database AAA, or you use the AAA server to authenticate the user. You must authenticate this user, whether it's real or fake or bad guy or good guy. So you have to authenticate. Okay, the next step is step 3 is to add user's ACL entry. The entry you already had, the user's ACL, probably the extended ACL. Allow telnets to router, that's it. Dynamic entry, allow authenticated user, deny everything else. The fourth one is the access internal resources. So you cannot access internal resources after all said and done. Okay, when to use dynamic ACL? Where do we normally use dynamic ACL? Because extended is enough, right? Where do we use dynamic ACL? When you want to, you want a specific remote user or group of remote users or specific user to access a host within a network. You just want them to access a host within a network, connecting from their remote host via the Internet. They will connect from their remote host via the Internet. So this is when you need a dynamic ACL. This is when you need to use the dynamic ACL. When you want, or again, another way or reasons for using a dynamic ACL is when you want a subnet of a host on a local network to access a host on a remote network. So you want is a subset of hosts. You know, there are many hosts now. A subset of hosts on a local area network to access a host on a remote network that is protected by firewall. That's also when you use dynamic ACL. Okay, a remote network host that is protected by firewall, and you want from your host system a subset of your host, some reasonable workstation from your computer to access a protected file system in a remote area. Then you have to configure a dynamic ACL to enable this. Dynamic ACL example. So you can see this is a good example in that case. You see, this is some host, this switch 1, switch 2, they are using, this is a different network. This is a LAN because they use it, although it has 2 switches, this PC1, PC2, they are in this connected to this router, and then this router to the rest, another part of the world, and then to router 3, which comes to this switch, and then to this PC. So PC1 uses Telnet to connect router 3 and authenticate it. This PC1 uses what we call, because it's in a remote network, uses what we call the Telnet to connect router 3, to connect to router 3, to move all the way to this place and to authenticate it. So you need a Telnet. So when you're about to do that, then you have to have what we call dynamic ACL. Okay, it needs a Telnet protocol in order to be able to do that. Okay, so and then within a given time allowance, PC1 can use the file transfer protocol and the hypertext HTTP to connect to router 3 as well. Okay, so these are the configuration you make for this dynamic ACL. Router 3, you configure router 3 to be able to access here PC1. Router 3 config hashtag username student password Cisco, and then router 3 config hashtag access list 10 permit TCP any host. You put the IP address, okay, Telnet. Then these are the things you configure in order to access, to be able to communicate. Okay, now let's move on. You remember anything you configure, after you say exit, you have to configure for the interface VTY04. Okay, and then you want local login. Okay, once you do this, then you are good to go. Now, time-based ACL under advanced ACL. Time-based ACL, this is the one ACL that you configure using specific time. You set time that the users in your network can access. The users in your network can access the web, the internet. Maybe you can see during lunchtime, 12 noon to 1 p.m. 12 noon or 12 p.m. to 1 p.m. So you know it's break time. So that's when you have to configure the router. That's when any user, any PC in your network can access the internet. Okay, these are called time-based ACL. So this type of ACL that you configure that allow access control based on time of the day or week is called a time-based ACL. So like people working in your organization, you can prevent them from browsing by denying access to the internet from your network during the working hours. Maybe during the break time and 5 p.m. or 7 p.m. depending on when you close. That's when you enable them to access the net. Okay, these are the steps for creating time-based ACL. The first one is to configure router 1 config time range every other day. Router 1 config time range periodic Monday, Wednesday, Friday, 8:00 to 5 p.m. Step 2. So you are saying this time, Monday, Wednesday, Friday, all this one, from 8 a.m. to 5 p.m., they will be busy. They will not access the internet so that they can be able to focus to do their job. Router 1 config access list 101, permit TCP, you put the IP address 192.168.10.0, you put the subnet up to 255. Okay, any telnet, time range, every other day. Then step 3, router 1 config interface serial 0/0/0, router 1 config interface hashtag IP access group 101 out. So these are the 3 steps you use in creating your time-based internet, time-based ACL. Is that okay? Now, time-based ACL example. Here is an example. Users are not allowed to access the internet during the business hours, right? They are not allowed to access the internet so that they can be busy doing your job. They can be busy working. They are not allowed to access the internet during the working hours, because if you don't create this time-based ACL to prevent them from accessing the internet during working hours, you will be paying them, but they are using your internet to browse, to do other things, or to even find better jobs. So users are not allowed to access the internet during business hours, except during lunch and after hours, like between 5 p.m. and 7 p.m. when your office would have closed. So, like for example, look at this staff, okay, working in this organization. He said, I can't solve the web at 10 a.m. because of time-based ACM. You see? So when you are working in an organization, you cannot use the internet at certain time. It's because their system they've created a time-based ACL. So you cannot, a technology that they use to prevent you from accessing the web. Okay? So now, how do you configure it? How do you configure the time-based for this type of case to ensure the workers they only have access to internet during 12 in the noon time, 12 to 1, and beyond 5 and 7. Okay, router 1 config time range employee time. See, that's the first thing you write in your command line interface. Router 1 config. Okay, apart from using a command line interface, there's what we call the Cisco Configuration Professional. Okay, we use it for configuration. Cisco Configuration Professional is a software for configuring all of these things. Now, we say router 1 config hashtag time range employee time. Router 1 config time range periodic weekdays 12:00 to 13:00, meaning 12 in the day to 1 p.m. 1 hour time. So that's when you can access the internet. Router 1 config time range periodic weekday 17 to 19, meaning by 5 p.m. to 7 p.m. you'll be able to access also the internet. Router 1 config time range exit. After that, you put the network. Say router 1 config access list 100 permit IP address, put the IP address up to 255. Anytime range employee time, and then you put deny IP if any other thing, deny it, and then interface fast internet 0/1, and then access group 100 in anything that is going out, and then you close exit. So that's that for that. Now let's move to troubleshooting ACLs. How do we troubleshoot ACLs? ACL troubleshooting commands. Let's take a look at them. So we'll run through this one very quickly. Two commands are, we'll just look at the commands, okay? The show commands. So two commands are very useful for troubleshooting ACL. Show access list, that's the first one. This is number 1. The show access list command. Number 2 is the debug IP packet. These two commands are used to troubleshoot, because when you run these commands, it will show you where the problem is. Whatever is not matching, whatever, you see, when you run this one, it show access list 100. See, the first command, show access list. You type show access list in your command line interface, it brings everything out. If there's a mismatch, you will see. Whatever the problem is, you see. Then the second one, let's see the second one for this network. You say the show access, this is for the show access list. Show access list. Let's see for the debug IP packet. Debug IP packet. You just write hashtag debug IP packet. It will tell you what is denied, what has been forwarded, and what the problem is, to display everything for you. Okay, so the point we're making here, the point we've made here is that when you're troubleshooting in an ACL, when you're troubleshooting an ACL, you use these two commands: show access list and debug IP packet. Okay, show access list and debug IP packet. The next one is mitigating attack with ACLs. How to solve the problem. Any attack on ACLs. How do you solve the problem? Mitigating attacks with ACL. ACLs can be used to mitigate many network threats. You know, these hackers, these freakers, these phishers. So you use ACL to create a firewall to mitigate your network from being attacked. So how do you do that? One, by IP address spoofing, inbound and outbound. Another thing is DSTCP, synchronous attack. Another one is DOS smooth attacks. DOS is a denial of service, okay? Denial of service smooth attack. Then another way of mitigating attack with ACL is using what we call the ACL can also filter the following traffic. ACL can help us to filter the ICMP messages. ICMP is for messages, a protocol for messages, okay, for sending messages. So ICMP messages, both the inbound and outbound message, and tracer route. Okay. Now let's take a look at, do not allow addresses to be spoofed. If your address are spoofed, then hackers will get access to your system. Deny IP packet containing the following IP addresses in their source field. For example, any local host address to 127.0.0.0/8. Any reserved private addresses, deny it. Any address in the IP multicast address range, deny it. Okay. So inbound serial 0/0/0. How to do the configuration? You just say router 1 config access list 150 deny IP up to 255.255.255 router 1 config access list. So you see, deny. So you don't let these guys have access to your network. Okay. You deny the host, put the IP address, put everything deny. Okay, now do not allow addresses to be spoofed. Okay, still on the same thing. Do not allow any outbound IP address with a source address other than a valid IP address of the internal network. Do not let it. Okay, so how to do that? You create an ACL that permits only those packets that contain source addresses from your network, and deny every other one that is available. Okay, so you say router 1 config for the inbound. You put the interface access list 105 permit IP 1. This is yours. You are telling it to permit IP. This is yours that is going out from your network. Permit. So you block the outbound and you open the inbound. Okay, IP address 192.168.1.0 is up to 255 any. Now let's take a look at how to protect the DNS and SMT, simple management transfer protocol, and file transfer protocol. So DNS, SMTP, and FTP, they are common services that often must be what? Allowed through a firewall. You must allow this protocol through a firewall, right? Usually. The services. So what do? You say outbound on interface F0/0, this one, on this interface. Access list 180 permit UDP, any host 192.168.20.2. Okay, domain. Okay, permit this one. And then router 1 config access list 180 permit TCP. Both UDP and TCP have to permit both protocols. Any host 192.168.20.2. Okay, SMTP. Okay, router 1 config hashtag access list 180 permit TCP any host 192.168.20.2 FTP. So you are permitting all this, both the domain name server. This one, remember, this is a domain name server, DNS. And then FTP file transfer protocol. So all of them, you are enabling them, okay? So after you put this general, then you put their address with subnet mask, okay? So the next one is filter ICMP. Like we said, ICMP, remember we said, is used for messaging. And hackers usually use this, they hide under this to always hack us. Hackers, they use the ICMP packet for pinging and for sweeping, and also for causing what we call the denial of service flood attack. So they use it to carry out pinging, sweeping, and causing denial of service flood attack. And they also use the ICMP to redirect messages to alter the host routing table. They redirect it to alter the host routing table. Both the ICMP echo and redirect messages should be blocked inbound by the router. Should be blocked. What should we do? Here is the attacker. Here is the target. So they send what we call the ICMP echo request. Okay, so you give ICMP echo reply. If you send again ICMP echo request, then you give reply. So if it's coming from this type of thing, then you should block it. Now, filter ICMP message. To filter it, we have to use these ones, these words that we've used: ICMP echo reply, ICMP echo request, then ICMP echo reply, and so on and so forth. So once you use echo request and echo reply, and what we call the source quench, then the unreachable, once you do all of this, you will be able to prevent this kind of attack on the system using by the attacker using hiding under the ICMP to steal from you. So what you do on your inbound serial interface, router 1 configure hashtag access layer 150 permit ICMP any echo reply. Router 1 configure hashtag access list 150 permit ICMP any source quench. You type for each of them, for echo reply, for source quench, and for reachable. Okay, these three things you must configure them in your interface. The next one, then you now deny as any other ICMP. You have enabled the echo reply, you have enabled your source quench, you have enabled your unreachable, but you deny any other ICMP. You are denying any other ICMP. So you now configure access list 150 permit IP any. Okay. Now still on filtering ICMP messages. Several outbound ICMP messages are required for proper network operations. Number 1 is the echo. Number 2 is the parameter problem. Number 3 is packet 2B. Number 4 is source quench. Okay. Number 1, which is the echo. Echo allows users to ping external hosts. It allows you to ping an external host. Now, number 2, we say there's the parameter problem. The parameter problem helps to inform the host of packet header problems. So anytime there are packet header problems, this will help to inform us. The third one is the packet too big. Packet too big required for packet MTU discovery. Then source quench throttles down traffic when necessary. Helps you to throttle it down when necessary. So what do you need to configure? You need to configure all this one. First one, configure echo. Second one, configure any parameter problem. Third one, configure any packet to be. Fourth one, configure any source quench. And then deny. You start to deny any other ICMP, and then permit the IP address, any IP address. Now let's go to IP version 6 ACLs. Let's go to IP version 6 ACLs. IP version 6 ACL configuration. Okay. IP version 6 ACL, they are similar to IP version 4 ACL that we've talked about. Now, this type of ACL, they allow filtering on source and destination addresses, source and destination port, and the protocol type, just the same way the IP version 4 that we've described earlier on. So IP version 6 ACL are created using the IP version 6 access list command. Now, what's the specific access list command? It's just that you have to mention the IP version 6 access list here. And every other thing you put it as it were before. So IP version 6 ACL, they apply to any interface using IP version 6 traffic filter. So you must measure the IP version 6 traffic filter in order to both the inbound and outbound command to be recognized. Now, IP version 6 ACL implicit entries. So anytime we are keying, all IP version 6 ACL contains two implicit permit statements to allow IP version 6 neighbor discovery packet to be sent and received. Okay, to be sent and to receive. Okay, so permit ICMP any NDNA. Permit ICMP any NDNA. Okay, so it's same like IP version 4. Now let's go to object groups. Using object groups in ACL, object groups are used to classify users, devices, and protocols in groups. Now, these groups can then be used to create access control policies for groups of objects in easy to read way. Okay, so why do we use object groups? Object group. Why do we use object group? Here you can see there are 3 servers in this topology. We have one here. We have one here. Okay, sorry. We have one here. We have another one here. We have another one, another server. So we have, in this arrangement, this topology, we have 3 servers. Okay, and each one has its own address. See, .1, 10.10.10.1, 10.10.10.2, each one has its own address. So we have to configure based on this. Without object group, we have to configure a permit statement for each server, for each protocol. So we have to, without object group, we have to configure a permit statement for each server. So when there's object group, it helps us a lot, right? Okay, so now let's move on quickly. Object group example. For the same topology using object group configuration, first create the service object for the services. You configure the object group, service web, TCP, SMTP, TCP, World Wide Web, and HTTPS. So you configure this, first you configure this, then you create the network object for the server by saying config object group network web server. You put the address. Then finally you create the access list by saying access list extended in config access list in the permit TCP any object group web server object group web server. So you configure all of this, then the object group is established. Securing network with firewalls. How do we use firewalls to secure our network? First of all, let's say a firewall helps us to prevent undesirable traffic from entry prescribed area, right? Any undesirable traffic. By undesirable, we mean a traffic that we don't want. Okay? So a firewall helps to prevent any undesirable traffic from entry any prescribed area within a network. So firewall is a system or group of systems that enforces an access control policies between one network and another. Okay, what can come in, what cannot, what should be returned back, what is blocked, what is prevented, what is allowed to come in. So that's what a firewall does for any network. Example, a packet filtering router, a switch with 2 VLANs, multiple hosts with firewall software. Okay. Now let's take a look at a good example of firewalls. You take a look at this. This is from the web. This, let's assume this is your network. So whatever is allowed to go in, you see this blue, meaning it's able to, again, it has access. See this red, they don't have access to this network. So this is a firewall. It prevents this unknown users from getting access to this particular network. So all this will be denied because they are unknown. And then what is allowed is allow web traffic from any external address to the web server. Allow traffic to FTP server. Allow traffic to SMTP server. Allow traffic to Ethernet IMAP server. Deny inbound traffic within the network addresses matching Ethernet register. Deny all inbound traffic. Deny all inbound ICMP echo request traffic. Deny all inbound SMI active directory. Deny, you see, deny. So all this deny will not be able to access your network. Now let's take a look at stateless versus stateful packet filtering. Stateful packet filtering is an advanced ACL, while stateless packet filtering is just an ACL. Now let's take a look at the difference between them. Stateless packet filtering, ACS, like I said before, they are just ACL. ACS filter traffic based on source and destination IP address, TCP and UDP port number, TCP flag, ICMP types and codes, and so on and so forth. That's for stateless packet filtering. What about stateful packet filtering? It does inspection. This one does inspection to remember certain details and or the state of that request. It finds out certain details about state of a request that has been made. Then it maintains record of all connections that will be established or that have passed through the firewalls. Maintain all the connections of all the things that pass through the firewalls. Then a stateful firewall monitors the state of connections, whether the connection is an initiation, data transfer, or termination state. So it will monitor all kinds of connections that has been established. Okay. Now let's go to packet filtering firewalls. Still on more packet filtering firewalls. Now packet filtering firewalls are usually part of the router firewalls and primarily uses the ACS to examine a packet based on the information in the packet header, right? And the packet filtering firewalls, they also use simple policy table lookup that permits us to deny a traffic based on the specific criteria that has been entered for that packet. Now, this specific information or criteria includes the source IP address, the destination. See, packet filtering needs to identify the source IP address, the destination IP address, the protocol type, the port number, source port number, destination port number, synchronization or the start packet receipt that has been established. So once all these things are there, then it will be able to filter through. Remember common types of firewalls. We have the packet filtering firewall and we have stateful firewall. We said the stateful firewall covers 3 levels. We've established this at the beginning. We said the stateful firewall, it passes through the 3 layers. Layer 3, layer 4, layer 5. That's the network, the transport, and the section. While just the ordinary packet filtering covers only 2 layers, the network and the transport layers. Okay, now stateful firewalls. Stateful firewalls are most versatile and are very common firewall technology that we use in today. Stateful filtering tracks each connection traversing all interfaces of the firewalls and confirm that they are valid before they enable them to pass through. Okay. Stateful firewall, we also call them the packet filters. The stateful packet filters. Okay. The stateful firewalls, they have 2 common improvements over packet filters. The stateful firewalls, they have 2 common improvements over the packet filters. One is The number one improvement it has over the packet filter firewalls is that they maintain a section table. The stateful firewall, they maintain a section table, that's the state table, where they track all the connections. Then they also recognize dynamic applications and know which additional connection will be initiated between the endpoints. Okay, now let's go to still on stateful firewalls. Stateful firewalls inspect every packet, compare the packet against the state table, and may examine the packet for any special protocol negotiation. Okay, stateful firewalls operate mainly at the transport TCP UDP layer. Okay, so this is an example. Cisco iOS firewalls TCP handling. Okay, so we have the source address, the destination address, the source port, the destination port, initial sequence number, the acknowledgement and synchronization, and so on and so forth. So this is a stateful special algorithm, okay, that we expect all of this to check the source IP address. This red, it's a firewall, like blocking anything that's coming. I need to check. The algorithm will check the source IP, the source port, destination IP, destination port, and sequence number, and so on and so forth, before a connection will be established between this network or this computer on this network to the computer on our network. Okay, before communication will be established between them once it's verified. Is that okay? Now, other types of firewalls. We have application gateway firewall. This application, it covers 3 layers in the OSI model. It includes the application layer to the stateful. It covers the first 3 layers of the stateful firewall, which is the network layer, the transport layer, and the section layer. And it also has the application layer 7, the application layer. So it's not only 3, 4, 5, it's 3, 4, 5, and 7 layer, this application gateway firewall. And the application gateway firewall is simply called the proxy firewall. Okay, so I think these are the basic things we need to know. And then we have another type of firewall, apart from all we have studied, called the address translation firewall. Address translation only covers, it's just like the stateless firewall or the packet filtering. It only covers the network and the transport layer in the OSI model. Okay, still another type, we have the host-based server firewall. The host-based firewall, here, a PC or a server with firewall software running on it, that's it. You just have a computer and a firewall is running on it. We call it the host-based. It could be server, it could be personal, or your computer. Host-based firewall. Then another type of firewall is the transparent firewall. A firewall that filters IP traffic between pairs of bridged interfaces. Then we have hybrid firewall, a firewall that is a combination of various firewall combined, put together. It's called the hybrid firewall. Okay, now let's go still on firewall design. How do we design firewall? Simple firewall design. Firewall design can be as simple as having an inside network and outside network using 2 interfaces. The inside network is called the private network, is the trusted one, and the outside one is your trusted one. The outside one is the public and is your trusted one. So we're going to work on both the inside and the outside. Model firewall design. Design involves 3 or more interfaces on the firewall. On one side of the network, traffic to the outside is freely permitted. Traffic to the demilitarized zone is freely also permitted. Then that's one inside network. One outside network, traffic from the outside is generally blocked entirely unless it's associated with traffic originated from the inside of a demilitarized zone. Then one on the demilitarized zone network, the traffic from the outside should be very specific, such as the email DNS, HTTP, or HTTPS traffic. That's when it will be allowed to pass. Traffic to the outside is freely permitted. If you are sending outside, it's very permitted. Now, model design. This is the demilitarized zone. This is the trusted, the private one, our own network. This is the public one, the internet. Okay, you see here, you can set to the demilitarized zone and come. Packets can go and come back. Traffic can go and come back within the private and demilitarized one. But between the demilitarized one, packet can only go out of it. See, packet going out of it, they are from the demilitarized zone. All the packets that are going out, they are blocked. They are not allowed to enter the public network. But from public network can go to the demilitarized zone. Then from the private network, we can send to the public, your trusted, but they cannot come. Traffic cannot come into is blocked. Any traffic from the public that is trying to enter the demilitarized, the personal or the private trusted network will be blocked. Okay, so let's move on. The Cisco iOS firewall feature set. These are the features. It has a NAT, a standard and extended ACL, Cisco iOS firewall, Cisco iOS IPS, IPSec, network security, TCP. So these are the things that are needed. Here are some misconceptions. We all think that firewall is all that is needed to ensure a safe Ethernet network. Although a firewall is needed, but it's not all that is needed. It helps, but it's not all that is needed, okay? There are other few things that you need to also do. You need a significant number of intrusions. A significant number of intrusions, such as viruses, come from hosts within the network. So you need to find how to deal with this, maybe by installing antivirus and so on and so forth. Firewalls do not protect against rogue modem installation. So if there is a rogue modem installation within your network, then firewall cannot protect it. Remember, firewall is only protecting what is coming from the outside. Firewall is not protecting what is inside within the inside. So if there is a dubious installation of a modem, people came to fake a wrong modem in your network, then your firewall cannot protect it. So people can disguise to be your internet service provider. If you have problem, they come and then they install a fake modem in your district to tap into your network. So in that case, firewall cannot save you. So firewall has its own limitation, but it will save you from anything from the outside. But within the inside, you have to work on that. Okay? Firewalls do not replace backup and disaster recovery mechanisms resulting from the attack or hardware failure. So when there are hardware failure, it's not the job of the firewalls to help you to recover any attack on your system. Firewalls is no substitute for informed administrators or users. Okay, so these are the defenses. This is World Wide Area Network. This is a firewall. Okay, see, protected this system, protected all this system. This is a firewall. This is a firewall protected all this system. So this is defense in depth. There are 4 layers of defense in depth. The outmost layer, which is this blue one, is called the endpoint security. The endpoint security provides identity and defense security policy compliance for defense or for network. Communication security is this one. Communication security layer. Provide information assurance, this one, just to assure us of the availability of information. Then the third one, this one, which is the gray one, this gray, is the perimeter security. Perimeter security now, this is where a firewall is needed. It secures the boundary between the zones. This one secures the boundary between the zones. Then the last one, which is this one, network core. Network core security. Core network security protects against malicious software and traffic anomalies, enforces network policies, and ensure survivability. So like antivirus, all of they are within your network core to ensure that People do not bring this thing to corrupt your system. The firewalls is between, it's a gateway between this place and this place. You have to build your firewall somewhere here in the perimeter facing or perimeter security. Okay, so let's move on. ISR routers. A Cisco routing running Cisco IS firewall is both a router and a firewall. There are some routers that are configured like this one. You see this one, this type of router. They are router, they are also firewall. So you know you can configure your router to act as firewall and at the same time as routers for you. So what it means is that if there is any two firewalls, one design option is to join them with a local area network functioning as a demilitarized zone. Okay, so to join them, you need a local area network that will function as a demilitarized zone. Okay, so it also provides hosts in the untrusted public network redundant access to the demilitarized zone. So the hosts in the public networking have access to this demilitarized zone. Okay, now zone-based policy firewall. So this is, I think this is the last segment of the firewalls, but it's still a lot. Last segment of this firewall that we looked at. What's the benefit of zone-based? You can call it a zone-based policy, or you just call it ZPF. That's zone policy firewall. There are many names for it, or many abbreviations for it. So this zone-based, one of the benefits is it is not dependent on ACL. It's completely a different thing. It's not dependent on the ACL firewalls, okay, technology. So we say the router security posture is to block or less explicitly allowed. That's the job it does. Policies are easy to read and troubleshoot with C3PL. And one policy affects any given traffic instead of needing multiple ACS and special action. So one policy will only affect one a given traffic, not all. Zone-based policy firewall. So the name, you can call it ZPF, ZBF, ZFW, whatever it is. It was introduced in 2006 by Cisco. Okay. Now this with zone-based firewalls, policy firewalls, the interfaces are assigned to zones. Then a special policy is applied to traffic moving between the zones. We're going to see this in the coming time. The basic of ZPF zone topology. We have the demilitarized zone, we have the private network, and we have the public network, which is there. And this is a router, acting as a router and acting as a firewall. Okay, so a firewall, a router configured to be a router, also configured to be a firewall. So to protect these three zones, So in creating zone-based, this is how to create zones. Zone-based, if a new interface is added to the private zone, if you bring any new computer, any new interface, if I draw a new line, for example, in here, okay, let's say if we introduce any new interface, like it could be a workstation, okay, any new interface. If a new interface is added to the private zone, the host on the new interface, this one is the host now, this computer that we drew here. The host on the new interface can pass traffic to all hosts in the private zone. So it can pass traffic to the private zone. See, it can pass traffic to this private zone because everything is connected in this zone, but not to this other zone or this other zone. Now, the new interface also inherits all existing private zone policies when passing traffic to other zones. So the new interface also inherits all existing private zone policies. So this new one will inherit all the private policies. If he wants to pass traffic to any other zone, he must adhere to the policies. He must adhere to the existing policies in this private zone. All the policies must follow. This new host that you created must follow all the policies that within this private zone. in order to pass any traffic to any of this one. Is that okay? So that's just for zone based. Now it has three actions. There are three actions of zone based: the inspect action, the pass action, and the drop action. Inspect is to configure the Cisco iOS SPI, which is equivalent to IP's inspect command. It automatically allows for return traffic and potential ICMP messages for protocol requiring multiple parallel signaling and data sections, e.g. the file transfer protocol H.23, and inspect actions also handles the proper establishment of data sections. So one of this is for inspect. Three action: inspect, carry out inspect. The second one is to pass. The other one is to drop. Okay, the zone base. Now let's take a look at the rules. A zone must be configured before it can be assigned to a zone. You have to configure it in the CCP, the Cisco Configuration Professional, before you assign it to the zone. We can assign an interface to only one security zone. Okay. Another rule is that if the traffic is to flow between all interfaces in the router, each interface must be a member of the zone. If you want traffic to flow between the interfaces in the router, each interface must be a member of the zone. Traffic is implicitly allowed to flow by default among the interfaces that are members of the same zone. So to permit traffic to and fro a zone member interface, a policy allow or expected traffic must be configured between the zone and any other zone. So these are the rules that we need to follow when we are creating zones. Okay, the safe zone. Okay, these are rules for safe zone. Now let's move on quickly to configuring zone. This is important. So how do we configure the zone-based policy firewalls? Create the zone for the firewall. That's zone security. The second one, define the traffic classes. Example, you write class map as the type of inspect. The third one is specify the firewall policy. You say policy map. That's the type of inspect. You know, the class is class map. This is policy map for the policy. The fourth one, apply the firewall policies to pair of source and destination zone. You just say zone pair. Zone pair. Number 5, assign router interfaces to zones. You say zone member security. Finish. These are the key. These are the things you type on your CCP. Okay. These are the things you. These are the command you just or what you look out for, and click. Okay. These are what you look out for and click on your CCP. CCP is Cisco Configuration Professional. It's an interface for configuring all these zone-based firewalls. Is that okay? Okay, look at it. It's a final ZF configuration. Number 1 is create the zone. Number 2 is to create the zone. How do you create the zone? It's a zone security inside, zone destination inside. So number 1 is to create the zone. Number 2 is to define the traffic class. That's the traffic class. Number 3 is to specify the firewall policy map, class map. Then this one is policy map. Number 4 is to apply the firewall policies. Okay, number 5 is to assign the interface to the zone. Okay, these are the 5 things we do. Now let's go to the CCP firewalls wizard. This CCP firewall wizard is what we use to configure all this. Either you use to configure all your firewalls. Okay, because here we give you the interface to configure your firewalls. Okay, this is a software for configuring, Cisco design software for configuring all these things. So the first is configuring using the basic firewall wizard. The first is the ZenPF. Okay, the ZenPF can also be configured using the basic firewall wizard, right? In the zone-based, that's the zone-based policy firewalls can be configured using the basic firewall wizard. Okay, now here are the steps. The first step is from the Cisco CCP. Choose the configure. If configure this interface, the configure term. Then you go to security, and then you go to firewall. Then number 2, step 2, and you create the firewall tab. Click on the advanced firewall option. and then click on the launch the selected task. Then the third step, the advanced firewall configuration wizard window will appear. Then you click next to begin the configuration. So these are how to navigate. Okay, look at it. Look at it. The basic wizard firewall. You know, the first one was to click on configure, right? After configure, we go to where? We go to create firewalls. Then we click on advanced firewall. So after you click, you see, if you click on the configure, it gives you these three options. Either you want to create a firewall, you want basic firewall, you advanced firewall. You click on advanced firewall. It gives you a launch the selected task. Okay. This is what the interface you see in this wizard. You click on launch the selected task. Then it will take us to this next interface. Once you click, you see config, security, firewall. Okay. So launch the selected interface. You click on this interface serial 0/0/1. Click on this interface for the outside, your trusted one. And then for the inside, you know what you have. A fast Ethernet 0/1. You click on this for the inside. And then you click on the next, right? Then we get to the next one. So this will take us to this interface. Advanced firewall security configuration. See low, this low, this high security. So you can adjust this. You can adjust this. You bring this description. Click on the use a default Cisco CP application security policy. Click on this. Okay, then you go to next. It will display this one. Firewall wizard. It gives you all this. Fire configuration summary. It gives you all the summary of what is to do. Okay, so then you now begin to enter you see the system, see the router, see ISB, see the firewall that has been given. You select, see the deny this, deny that, permit this, any, permit all of this. So you play with all of these things, what you want, what you don't want. These are firewalls and ACL. So this wizard can be used for configuring or verifying firewalls. Okay, you see the fast Ethernet, the serial interface and everything. So this verify your network. Okay, then once you do that, it displays and monitor the firewall. This one for monitoring your firewall status, tells you all the status. This is a Cisco configuration professional that we use in that. Now manual Z, we say the manual ZPF uses this CCP. Configure ZPF uses the CCP now, Cisco configuration professional. There are 4 steps to configure ZPF using the CCP. Define the zone, configure class map to describe the traffic between the zones, create policy map, define zone pairs. Now you pair the source and the destination, and then you are good to go. Okay. Or like the CCP basic firewall wizard with manual CCP ZF. So if you are using ZF, you know the one we did before was for the normal firewall wizard. This is now for specifically for ZPF. Okay, you have to create zone anytime you are doing, because that's why it's called zone. You create the zone pairs, traffic classification, policy map, and then the application. So you have to do all of this. Okay, look at it. Define the zone. So you come here, configure security. We have to define the zone, right? Okay. Okay. So here we have to carefully see which zone. Okay. So here we define the zone. It's for zone. See? It's for zone. Okay, we have to look for zone here and click the zone and so on and so forth. Okay, let's move very fast. And then the next is the class, configure the class maps. Okay, the next step is the class map. Configure the class map. And then the next thing is the create the policy maps. Okay. And proceed the policy maps. Look at it. Look at it here. The one just now, sorry. Here, class map. The first one, the zones. See the first one, zones. Then the second one, a class map, a policy map. And then the next one is zoo pairing. Add the zoo pairs, the source and destination. Okay, you have to add the source zone and the destination zone. And then we now view a firewall policy. You now view it to show you what you have. Okay, the configuration. Okay, monitor active section. How do you monitor active section? This one will show you which one is active, which one is not, to display here to show. Okay, to show you all the active section. Then here is a view drop packet. Now to see drop packet, you see here we have active section, drop packet, allowed packet. So order the active section. You know we are monitoring the active section. Look at it. This is the active section. Other active section, we have drop packet and we have the allowed packet. So when we click on the drop packet, it gives us a graph. See, you can even use this one to do research. So you have to learn something here. It gives us the drop packet. So you can take out this result and make a research and make a publication out of this. Okay, so that's all we have for today. Thank you for joining our class.